Tell us a little bit about the more advanced techniques like EBSD. And what does EBSD stand for, and why is it a preferred technique for certain measurements?
Okay, so EBSD is of course an abbreviation for Electron Backscatter Diffraction. EBSD, Electron Backscatter Diffraction. And this is a technique which you use in mainly in scanning electron microscopy, which is this form of microscopy where you create a beam and at every place you create a signal. Actually, and once again, this is different from TEM where you create an image. So now this EBSD technique is one of the very powerful techniques which is available only for crystalline materials.
Okay.
Maybe this is not clear. Before I'm talking about the microscopy technique, I should shortly mention that not every material is crystalline, but many materials are crystalline. Yeah, if you take a piece of metal and you look on it, you would say, where is there a crystal? Actually, the piece of metal consists of many, usually micrometer large or 10 or 100 micrometer large small crystals, which are glued together with atomic forces, and these crystals determine very much of the properties of the material, all kinds of properties. So EBSD, electron backscatter diffraction, is a technique which is only accessible for crystalline materials. You cannot look on polymers, you cannot look on biological samples, except if it is a tooth or something like that, which is crystalline. You cannot look on glass with this. So we are limited to ceramics, to rocks and minerals, of course to metals and all its variations in the metallic field. That's the technique. That's where the technique works. And so what happens in this EBSD is you place a very fine electron beam onto your sample, and inside of the sample, the electrons travel around in all directions. They get actually scattered by the atoms, and then when they come out again, they feel information given by the crystallographic nature of this lattice, of this crystal, by the very regular arrangement of the atoms. And when you then place a detector very close to their sample, you can see this very nice regularity of the crystals in form of a regularity of the electron distribution in space.